Hello everyone, this is Shiva. So in the previous model we've seen uh, what is angular frequency when one charge is slightly disturbed, right? Uh, right. So this one, which is kind of another standard model of questions, right? So what they've given is two identical tennis balls, each having mass m and charge q. They're suspended from a fixed point by threads of length L. What is the equilibrium separation when each thread makes a small angle, right? Um, Small angle theta with vertical, and they're given some options, right? So if you see the scenario, this is a standard one. Most of the students are familiar with it, right? So two massless strings, at the end two masses are there, right? Each charge is q, right? Each mass is m. Since both are symmetrical, right? Same mass, same massless strings, right? And no medium at all, and same length, by the way. So I'm taking same separation, semi separation angle, that is theta and theta, right? And this is T tension, which will obviously develop because mass m will exactly act downwards, right? And this is T and this is theta. So if I resolve this into components, so this will be T cos theta and T sin theta. And due to this charge, on this charge there will be Coulombic repulsion in this manner, right? Fc. So since there is no motion of any sort here, so the system is in equilibrium. They themselves set, right, what is the equilibrium separation. So in equilibrium case, nothing is moving. So all the forces in all the directions, right, x direction, y direction, must cancel each other, right? So if you equate that, Fc is equals to T sine theta, this component equal to this component. And in vertical case, mg is equals to T cos theta, right? And if I take ratio of these two, right, T will cancel, and sine by cos tan is equals to Coulombic force by weight, that is Fc by mg, right? So Fc is equals to mg tan theta, right? By the way, since, well, there are three forces are acting here: T, mg, and Fc, right? There is no other. I mean, I just resolved T into T cos theta and T sin theta. All three are in the same plane, right? Coplanar, and three forces. So I guess something. I mean, you know, some theorem you can apply here. If you could think of that, nothing but Lamius, right? You could do problems from that also. Okay, so Fc is equals to that is Coulombic repulsion between these two charges, right? Kq square by r square. Equilibrium separation is, I've took it as r, and from symmetry I've took r by 2 and r by 2 here because everything is same here, m and m, l and l, t and t, right? So from here, from symmetry I took r and r by 2 and r by 2, and equilibrium separation is r. So Fc is kq square by r square, which I equated to mg tan theta. From here tan theta I got, and in the problem they mentioned that small angle, so small, when theta is small, tan theta I can equate almost to sine theta, which in turn equates to theta. They could they've asked in this manner also, right? So sine theta, from this one we can write opposite by hypotenuse, that is r by 2 by l, right? That is equals to this one, right? And if I take r square this side, so it will be r cube is equals to kq square 2l by mg, right? And if I take one, if I take r expression, then it will be 1 by 3. So that is what they've asked, right? What is the equilibrium separation? Yeah, so in the options they just said x, so I took it r, so same thing. So q square l by 2 pi epsilon naught mg whole power m by 3. Yeah, one more thing. So if, I mean, they wouldn't make it that much easier, but if they did, you could directly do it by dimensions. So 1 by 3, 1 by 3, 1 by 3, 1 by 3. So I think you could do it by dimensions also. So go through dimensional analysis. We'll go through it later, right? So thank you very much, and We'll do two or more problems based on this scenario. Another popular scenario on this same thing is, so when you immerse these two charged bodies, right, in a liquid of dielectric constant K, then since there is liquid, there will be some buoyant force which will be acting on these charges, right? And I'll discuss that in detail in the next video. Thank you very much.